Well, hello everyone, and welcome to the February Tech Industry Luncheon. I'm Paul Bindle, the Senior Vice President for Tech Titans, and glad to have you join us today. Hope everyone is safe and warm. If you are experiencing some problems with this new Remo platform that we are using for the first time today, there is a frequently asked questions section in the chat portion of the uh, program, or you may go back to the email where you received the link to today's program, and the FAQ is there as well, and it has some helpful hints on what you can do to be able to enjoy the program today in case you're having problems. The Tech Industry Luncheon is just one of many programs produced by the committees within Tech Titans. Whether it's this tech luncheon, the forum programs, innovation team, our talent team, whatever the case may be, Tech Titans is continuing the longstanding commitment to being a champion of the North Texas tech community. I mentioned Tech Tuesday. It's a unique new way to showcase our forums programs presented on the second and the fourth Tuesday of every month. The Health Tech Forum presents the next program on this Tuesday, February the 23rd. And you can check the Tech Titans website for information on that program, the Tech Tuesday schedule, the Tech Industry Luncheon, or any of the other programs that Tech Titans has. You can access all of that on the Tech Titans website at techtitans.org. The presenting sponsor of the Tech Industry Luncheon series in 2021 is the UT Design Program at the University of Texas at Dallas. Please welcome the Director of Corporate Relations for the Johnson Engineering and Computer Science, Don Purcell, to tell us a little bit more. Don?
Thank you, Paul. Good afternoon, everyone, and happy Friday. We hope everyone is safe and has power again. We lost our power for 2 days and stayed with our daughter in Richardson. Just got back to the house yesterday. Hey, say, how long has it been since you sponsored and mentored an amazing team of UT Design capstone students? Well, that's too long. This year, we're going to launch over 250 capstone projects with teams providing innovative solutions to their company sponsors. The vast majority of these are sponsored by North Texas companies just like yours. We have over 6,000 undergraduate students in the Johnson School, and last fall, our entering freshmen averaged 1,420 on their SATs. That's pretty darn good. These students build their engineering solutions in a world-class design studio supported by an all-star team of faculty directors and support staff. Key reasons why our student teams have won 9 national championships in 9 competitions since 2014. These corporate sponsors have learned that we can give them a team of up to 6 capstone students for less than the cost of 1 intern. They have 1 or 2 semesters to try out these students for possible entry-level positions in their companies, all while working down part of their engineering backlog that they otherwise would not be able to address. We welcome companies of all sizes, from startups to giants like Raytheon, State Farm, and TI. Today, we're signing up sponsors for engineering projects to launch in our summer semester beginning in May. Don't delay, it will be here before you know it. Contact me at information I'm going to put in the chat window shortly. And for more information about UT Design Capstone, visit our website at utdesign.com to learn how our students can accelerate your company's success. We are your engineering and computer science force multiplier. Back to you, Paul.
Thank you, Don. Appreciate the support that UT Design gives the Tech Industry Luncheon, and to Tech Titans, thank you again for being with us. If you wish, Don, you can put some information on UT Design in the chat for people to contact you. You can also go to the UT Dallas website for more information. Your ability to ask questions in Remo is a little bit different from some of the previous ones. We are going to request that all questions be put in the Q&A section. If you'll notice to the right of your screen, there is a box that has a chat room, the participants listed, and in the Q&A. You may ask your question in that Q&A. Do not put them in the chat room or we will not notice it. Rod Wetterskog and I will be monitoring that Q&A section, and we'll pose the questions for you. The Tech Industry Luncheon is pleased to have Jose R. Favilla, Jr. of IBM today with us. To introduce Jose and then moderate our Q&A, please welcome one of the members of the Tech Titans program team, the Assistant Dean of the Johnson School of Engineering and Computer Science and the Director of Presenting Sponsor UT Design, Rod Wetterskog. Rod, take it away.
Thanks, Paul, and good afternoon, everyone. Jose is the Global Industry 4.0 leader at IBM. He has over 30 years of experience working with clients in over 30 countries to help them improve operational and business performance. Jose specializes in applying advanced analytics, optimization, artificial intelligence, Internet of Things, and blockchain technologies to drive innovation and to create new approaches to tackle complex business and operations problems. He's accumulated an in-depth understanding of the asset-intensive industries, including natural resources, process, and discrete manufacturing. He served as keynote presenter and spoke in numerous conferences around the world. Jose is a member of the IBM Industry Academy, which is a select group of IBM experts recognized by their contributions to industry. Today, Jose will be sharing with us some of the work he's been doing with his clients around the globe to help them realize the promises of the fourth industrial revolution by leveraging advanced technologies and optimization, AI, IoT, edge, blockchain, and others. Now remember to submit your questions, as Paul mentioned, during Jose's comments. Put them in the Q&A tab in Remo. If you've seen your question, no need to duplicate it. Simply cast another vote for that question, and questions with the most votes will be addressed first. Audience, please join me in welcoming Jose Favilla to the February 2021 edition of the Tech Titans Tech Industry Luncheon. Jose, thanks for being here.
Thank you, Rod. Really appreciate the invitation to share a little bit about the work that we're doing with our clients around the globe. And good afternoon, everyone, and happy Friday. So what I'm going to try to talk today a little bit is about, how we are working with clients. I think the best way to convey our what we're doing is through concrete client examples, what we're doing with a number of clients in different industries there as well. So if you can please move to the next slide. I believe this Paul has the control.
I have to readjust. It's not working, so give me just a moment.
Okay, all right, yeah. So as I was saying, we're going to show a number of examples, but give you first the big perspective. What do we mean by Industry 4.0, right? As you, of course, all know, we are now in this fourth industrial revolution. I mean, it's a term, the Industry 4.0 was a term coined in Germany initially. And if you go through our previous three industrial revolutions, it was all about, driving improving the physical processes that we have in a plant. And this has a long history. If you go back in the 17s, right, that was all about bringing mechanization to the production processes, using steam power at that time, etc. Then if you go a little bit further in time, the division of labor in an assembly line was another one, with the introduction of electrical power over and above the human power there. In 1960s, we were focused on more bringing automation to the industry processes there as well, right? And then now we are always about digital, how we bring digital technologies that Rod was talking about, how we can digitalize the operations, the whole process as well. Okay, maybe we should have the slides in a minute, but let's see. There you go. If you can go to the maybe second slide. So as you're seeing here, the Industry 4.0 is a very broad topic, right? Talk about digital factories, the concept of a digital twin. You have the physical equipment, the physical product, and you have a digital version of the product that would allow you to understand in a better way, have better insights of what's going on with the product. One big topic is about the convergence we call between the IT as well as the OT. By OT, we mean operational technologies the technologies that are driving the operations in a given manufacturing plant, on a given oil rig, etc. IoT as well, the ability to put a sensor in being able to monitor movement, temperature, etc., vibration, and what's happening there. Cybersecurity is becoming more and more important topic, right? I'm going to talk a little bit more about cybersecurity in a minute. The concept of integrating vertically and horizontally across the value chain. By vertical, we mean from the top floor, from the business side, all the way down to the plant floor, as well as from horizontal integration, we mean across the product life cycle, designing the product, building the product, and connecting the product and feedback the process on how the product is performing in the field. Flexible manufacturing, we see more and more, the need of moving from one type of product to the next. The factories themselves are becoming much more, we call software-defined environments, as well as the connected products, and to drive a superior customer experience. How we are using a product in the field could be an industrial machinery, could be a smartphone, and whatever. The experience that we are getting with the product, right? Getting updates over the air, etc., becomes very, very important points. So the diagram that you see here on the right side is just about the key processes we see covered by Industry 4.0. We have the product chain, as I was saying, the design of the product, from design a product, do the product engineering, testing, validating the product in a computer-aided environment first, before you have to do that, the physical manufacturing. You have the value chain in order to order the parts that you needed to assemble your product, figure out how we're going to be loading our factories based on a given forecast or given the orders that you have for the client, deliver the products to your clients, and then you have the asset value chain, how we're going to be maintaining the product into the field. So all these parts are a big part of the overall Industry 4.0, the promises around this topic. If you go to, please, the next slide. Today I'm going to cover mainly on the manufacturing angle. Instead of trying to cover everything, even though we are doing work around all these dimensions in IBM, I'll cover mainly what's happening in the manufacturing itself in the plants. Yeah, if you can go to the next slide. Of course, as a company, IBM, we have been working with a lot of clients. If you can go back just to the previous slide, please. Yeah, we are talking a lot with many clients around the globe, right? So first of all, on the left side, if you look at how a given manufacturing company is organized, typically we have their headquarters where they have their business systems, could be SAP or any other application there. Typically, the company have a number of factories, and the factories are designed to support a given set of portfolio of products they produce. And then, of course, in a given factory, you have the machinery for the factories. And typically, the systems in a given plant are organized using one of the standards called ISA 95 that defines what are the functions that you have from different levels, starting from the physical machinery at the level 0, the sensors level 1, the automation systems level 2, the manufacturing management systems level 3, as well as the enterprise systems at the corporate side level 4 and 5. So they are organized this, and this standard also determines how the integration happens between the levels. In the middle part here is the conversations we're having with many of the plant managers or the CTO for our clients. Of course, a continuous quest in manufacturing is the continuous improvement. There's a single metric in manufacturing called OEE, overall equipment effectiveness, that basically is a combination between utilizing how efficiently you're utilizing equipment, production resource, a machine, how is the machine is available, how it's being maintained to produce good stuff, and the quality of the products being produced. So this idea of improving the OEE is a continuous quest in terms of driving continuous improvement. Of course, if you go to a given plant, they have a number of systems coming from different vendors with different suppliers. And typically, they are proprietary applications capturing the data and breaking what we're calling the silos from different parts of the plant is very, very important. The data capture, again, major important to allow you to make the right decisions. So if you go to a given plant, usually you have a plant that are very modern, that was built in the last few years, but you may have a plant that was built like 30 years ago. In other words, we say there is a legacy of plant applications that needs to modernize. Before we even embark into a digital transformation, you needed to understand the foundation you have in the plant and do the modernization there. Of course, assess the plant applications from anywhere. This topic became much more evident when, with the COVID situation we have. Imagine you have a plant, you have a technician in front of the machine, and you may have 5 engineers supporting the technician from a remote in order to be able to help on the troubleshooting of the machine. Cyber attacks is another major point. We see a major increase in cyber attacks overall, especially in the industrial environments. The cyber attack at the corporate level is all about protecting data. If you go to the plants, it's much more complex. We're talking not only protecting data, but protecting people. Imagine, for example, if a hacker gets control of one of your machines, they can explode the machine, can cause damage to the environment, etc. So it becomes a much more complex environment to tackle the cyber attacks at the plant level. And the last one, of course, manufacturing is a cost-sensitive function, right? So you need to, leverage on the investments being made. In other words, no rip and replace. You can go there and bring out these new capabilities, but easily this is not a feasible approach. Understanding what the customer have today and how can we build on the base they have becomes very, very important as well. So those in a nutshell are some of the main topics that we're hearing from our customers in the manufacturing industry. Of course, if you please go to the next slide. And now talking a little bit about the technologies, how we are now understanding very well the situation that our clients in the manufacturing industry face, and how we call digital technologies we can use to completely redefine how the work is done in a factory. The first one, I think we all know, of course, the Internet of Things is the ability really to put a sensor. The cost of the sensors decreased dramatically over the last, several years. And now we can pretty much measure everything. This whole IoT is one area that we are exploring in the factories themselves. Sometimes we work with clients retrofitting a given equipment, putting more sensors in, or the new products now, machinery would have much more sensors. So you can monitor the machine remotely in the field. AI, of course, artificial intelligence and analytics. Here we have a whole spectrum of capabilities that we can bring to the table. In the analytics side, for example, we usually have what we're calling descriptive analytics that describes what happened in the past, so we can understand with the mistakes or the situation that we face. We have the real-time analytics, what's happening now. We have the preventive analytics, what may happen in the future. Is this machine is going to break the next week if we don't take action? And you have a prescriptive analytics as well, that given the situations we have, what would be the optimal decisions we needed to make now to maximize the outcome. In the AI, we all see all the enhancements in the AI during the last decade, especially around the machine learning, how the machine learning technology has been evolving quite a lot. And the way AI is in a point now that you can have, for some processes, more accuracy in the AI compared to what a human can do as well. Another interesting point that we open with AI is the ability to process data, process text, and so on, and understand spoken language. So all of these are capabilities that we're leveraging as we speak. The next one on the top right is about edge. We are hearing a lot about the edge computing, right? This is ability to somehow, being able to process the data where the points being, where the data is generated, without having to move data around and trying to have a delay in this process. So we can take actions much more faster at the point of action where the data is being generated. And this is revolutionizing again, is another era in the computer science that the whole thing is decentralized again. As I think for us being around for some time, you have been seeing over the decades, the decentralization, of course, in the mainframe, the decentralization, the client server, the whole internet, now going to the cloud, the computing being centralized again in an environment where we can process the workload. And now we're talking about the decentralization being driven by edge computing there. Of course, mobile, being able to access the information anywhere, and have now capabilities around augmented reality and virtual reality to allow us to see things, to interact with people, etc., to learn, etc., in a much better way than before. Blockchain, is another interesting technology that we are using to completely redefine a number of new processes, from onboarding of new suppliers, new customers, to reinvent and have the provenance of where we are getting the information from. We are using this across a number of industries. You may have heard about one of the blockchains from IBM, on the food chain from farm to fork, how we can track, if there is a contamination in the food, etc. This is also very important. Software-defined environments. One thing that we're seeing more and more in plants, our ability to now redefine how your plant is being set up, right? By redefining the type of product you're going to be producing using software, a software-defined environment. And as part of this as well, we are seeing more and more 5G becoming a reality in a plant, more like a private 5G. Cybersecurity, as I mentioned before, very important as well. In the other technology we call intelligent process automation, how we can understand the end-to-end process that's being performed, let's say maintenance, and how we can infuse AI or learning capabilities to redefine how the work is being done. And the last one here is what we're calling hybrid multi-cloud. Of course, we all have been hearing the word cloud, right? And in fact, there's a public cloud, there is a private cloud, and there is, a bare metal running some workload in a physical machine on a plant floor, and there is even on the edge what we're going to be running in a device or in a industrial computer on the floor as well. This is the hybrid angle. And the multi-angle is more being able to run this workload in any cloud. Could be Amazon cloud, AWS, could be Microsoft, Azure cloud, could be IBM cloud, etc., giving the clients the flexibility to run the workload, whatever is more appropriate for them. So these are all key technologies that we are seeing, are the building blocks to allow us to change the way we do work in our factories there, okay? So if you go to the next slide, please. Now I'm going to talk about examples, how our clients are leveraging this technology to change the way they're doing business. This is a company out of Sweden. This is a global player company called Sandvik. Sandvik, they have several divisions. The work that I'm talking about here is in their mining and rock technology division, focused on supplying underground mining machineries. Imagine if you have this kind of machine under the ground, right? So how can you guarantee a number of things? Of course, we are using for this one IoT as the way to collect the data from the machines. The machines now are extremely instrumented. You can pretty much measure everything in the machine. So the first thing that is a very straightforward view is the maintenance. Is this machine is going to break? Or when is going to be the best time to do the maintenance, preventive maintenance, the machine. So you get a lot of signals from this. But with this client in particular, we didn't stop there. We look at also the productivity. So this company is a very major player in the industry, and they have 20 to 30,000 of these machines in the field. So they get information from different clients using the machines, right, using a fleet of machines, and they can provide guidance to their clients by understanding how much productivity they're getting from the machines to improve their productivity overall. Why another client with a similar set of equipments are being able to produce more compared to what they have. The other one is about safety. Of course, safety is a major point there. So is the operator following the safety procedures in order to operate the machine? And then, of course, providing support for the operators themselves. Right. So again, we are using IoT and a number of other capabilities to improve the productivity of the machines in the field. Right. Again, Sandvik produce the machine in their factories, they sell the machine, and here is the end client, in this case, a mining company using the machine in the field, how we can improve the productivity there. So that's one example of we're calling, using IoT to improve the real-time machine, performance by using the data we're getting from the machine. If you can go to the next slide, please. Yeah, this other one is a company in Malaysia, right? They produce memories for semiconductors, for computers, right? And again, the idea here is really to use the AI solution to inspect the quality of the products. So what we are seeing is that, for you to look at the physical assembly, as you can see here in this little picture, is very hard for us in a naked eye to understand if there's any problem in terms of the welding or any situation there, right? What was inspected, by a person now is inspected by an AI model based on this vision, to allow you to, check the quality of the products. And with this, you go most of the process from a kind of a sample base to 100% inspection, because now you can replicate this process is much more reliable than doing this by sample and by people there as well. And in fact, I forgot to mention in the previous slide, these slides can be available, and you have a link for a video as well, right? You can see, you can hear the story for the clients themselves on how they're utilizing these capabilities from IBM. If you can please go to the next slide. This is again, for you to, produce stuff in a factory, you have to get your parts, and the parts would come from a variety of suppliers that you have, right? So understanding your production plan and understand how we are going to be getting the parts from the factory, make sure that they arrive properly, that you're not going to go you have to stop your plants because you don't have the parts, but also make sure that they arrive just in time using the Kanban concept here as well. So again, this is one of the major automaker worldwide in Japan, where we work with them using one of our capabilities around optimization, right? And we have in fact a business partner called Decision Brain, and they co-develop the solutions together with IBM, and they are also providing the solutions together with us for their clients there as well. Again, the whole inbound logistics optimization, from the part suppliers to the assembly plant, that can become a very complex task. And again, it's not only figure out how much do we need, but also how we're going to pack the parts in the trucks that are feeding the plant, doing a 3D, space optimization, load optimization in the plants there as well. So another very interesting case, this one with a major Japanese automaker. If you can go to the next slide, please. Yeah, this is again edge computing. This is we have another small, a short video there if you want to take a look afterwards, is how we are creating intelligent robots, more or less. In other words, imagine you have an assembly line where the robots are, in this case, are producing tires for the cars, and you need to check the quality of the tires. Can a robot, together with equipped with vision and the ability to process the data in the robot itself, using edge computing, perform in an intelligent way and take a decision if this is a good part or a bad part and what to do with it as well, right? Another very interesting case where we are now changing the way, in other words, the physical equipment, the robots in this case, perform their operations in the factory. Okay, so that's the example here on edge computing. If you go to the next one, this is again ability to use augmented reality in particular on how we collaborate with experts. The point that I was making before, that we now need to provide the ability for a technician that are in front of the machine, right, perform the work using either AI models or establish a collaboration with the engineers that are maybe located in some other place. And not only this, being able to communicate, being able to be guided through the process if you have to bring a schematic of the equipment, and also only this, capture the learning, more or less. So next time around to have a similar situation, you can use the scenario that we used before, so the whole thing is captured properly. And we are working more and more in bringing natural language as well. We don't even need to somehow input the data. You can talk with the system as well in order to better collaborate. Imagine like a person, in a situation where he has his two hands kind of being used to do something else. So being able to type, and this is not practical. So we are exploring more and more, natural language as one of the ways to interact with the application there as well. Maybe next slide, please. Yeah, this is another one. Is again how we are using blockchain in manufacturing. We all know about 3D printing, additive manufacturing, right? So this is becoming more and more a reality, from a dentist to many other places, and you can now produce much more, sophisticated parts that were not possible to do in the traditional, manufacturing process before. But what's happening is that now we are starting having more and more printing shops. In other words, if you have to print a given part in a given location, you may contact a printing shop that has capabilities for that part, for them to print the parts for you. But the issue is now, how do you protect your intellectual property of the parts? You may have a very expensive design that you did, maybe the example here, right? You want to make sure that, the company printing this for you is not going to steal your design from you and start printing more parts afterwards. So we are using blockchain to create a process where the company would have access only for the X amount of parts they were allowed to print based on the condition, the commercial arrangements between the supplier of the parts and the printing shop for the parts. Again, is a way to use blockchain. We are doing the work with this company, I think also well-known, a company in Germany called ThyssenKrupp, right? So they're the ones that they are having a number of designs for their parts, and they're collaborating with a number of printing shops around the globe. And the blockchain technology is one of the key enablers for this whole process to happen in an efficient way as well. Next slide, please. Yeah, this is, again, implementing software-defined environments. In this case, is one of the major player in the chemical industry, major chemical producer. And, in this company, they have a very complex environment, as you can imagine, a chemical plant, very large. And they were trying to do a number of things before, and they have the network, the old network they have was the major constraint. So we work with this client to bring private 5G network to somehow being able to be the glue to allow them to implement a number of other efficient processes in the plant. Not only give them more capabilities in the network, but also reduce the cost of the network as well. Again, my point is the 5G is becoming slowly a reality in several of their clients and open the doors to a number of other cases that they are implementing as we speak. Next slide. If you can please go to the next one. Yeah, this one is the point that I was making about cybersecurity in the plants. We call OT security. No, doing security in the IT side. Great. We have, many companies have a lot of capabilities in this regard. Here we are working with a company. It's a company out of Switzerland, but it's a major global player, ABB as well. And the ABB has a number of equipments, automation equipments they deliver for their clients. And the collaboration that we have with ABB is really to somehow connect their PLCs, their control systems, etc., right? In such a way that they can provide events to another solution that we have in IBM in order for us to detect any anomaly that's happening in the machinery. Any deviation from the standard procedures, etc., we can capture and we can provide intelligence on what's happening. We can stop the attack immediately or take actions to avoid this to become a broader issue. Again, work with a number of clients. ABB is the first one, but we work with several other business partners to bring cybersecurity to the OT environment there as well. Okay. The next one, please. This is an example, in fact, of a work we did with a company in Japan, right, to redefine how maintenance is done. If you look at the maintenance process in a factory, right, involves a lot of people. Typically, you have the machine operator in the front of the machine. The machine may be working well, but you may hear some noise or maybe a breakdown or whatever. Suppose we have a situation where we start listening to something is wrong going on with the machine. Of course, very likely the operator of the machine is going to call maintenance. I have some problems here and so on. And someone can take a look. The person would have to go enter in the system, the work order we call, for someone to go there and fix the machine. And then they have now to assign a person, right? Who is the technician that has the knowledge, has the parts, and what's the best time to go in to fix the machine. Then the technician goes into the machine, right, in front of the machine. With his own knowledge, he's going to diagnose the problem. He's going to, based on this, and he's going to change some parts, do this, do that, and so on. If the technician is good, experienced guy, right, we're going to get the problem fixed first time. And then, of course, otherwise, he thought he fixed the problem, but the problem is still there. So the knowledge is very, very important. The technician himself has to enter this information into the system. I replaced part number A, B, and C. I did this, I did the test, and so on, and return the machine back to production. And someone, of course, after this process, would have to figure out, do I have to order more parts? If you are buying a very cheap part, you may buy a lot of 100, or if you buy a very expensive motor, for example, you may buy one off or whatever. So managing your spare parts inventory, we call MRO inventory, become a very, very big task by itself. And companies have millions of dollars invested in spare parts. So it's a very complex process. It requires a lot of people and a lot of knowledge. So how we can redefine how maintenance is being done? If you please hit one enter. Just one more enter on this one. This is we call the automated process or the intelligent process. So just go back, please, on one slide. Yeah, if you go back just one slide. This one, we're explaining the bottom parts. How we are changing from the top, that's a typical process, to the bottom part. This is the one. So the first one, we call this process a cognitive maintenance. Not only getting the signals coming from the sensors in the machine, etc., to detect something is wrong, something is deviating from the normal behavior, but also what's wrong with this machine. Given that the temperature is rising very quickly, we have to shut down the machine immediately. Or this is the situation, we still feel like we have 1 month to fix the machine, not urgent. So understanding the criticality of the problem becomes very, very important. Again, we are using a combination between analytics and AI to do what we're calling cognitive maintenance. The second one now, instead of someone entering the order into the system, if you can just go back for the slide, the second step in the previous slide was about the idea of entering the order. You can have now an API to connect what we create as a problem in the machine automatically by the system and to create a new order. Please go back to the previous slide. Yeah, so that's the second step, understanding what we entering the ordering automatically this. And then comes the time to schedule an order. I mean, when we have to repair. Again, it's not only a single order. In a plant, we're talking about hundreds of maintenance orders happening on a daily basis, some more urgent than the others, some other ones that you have a little time to repair, and so on. You can do the repair over the weekend when the plant is in idle, and so on. Right. So understanding this process is an automated process there as well. And then comes the time, the force box on the bottom part is the technician part, right? When the technician now is in front of the machine. What we are seeing in industrial, there's a lot of erosion in terms of knowledge. The people that have been there for 30 years are retiring. The new engineers come on board. They still have a lot to learn, and this will come only with time. But how can we capture the knowledge and provide the guidance to a technician that's doing the repair as we speak there as well, right? So in other words, is a repair assisted by an AI system there. And not only doing the repair, as you go through interact with the application captures the data already for you. Then the last one is, again, optimizing your spare parts. Typically, we see that companies, they have much more than what they need of one part, much less than what they need from the other ones, but the net, they have much more than they need, more or less. They spend a lot of money, are tied up in spare parts. How do we can optimize the entire process there is another step in the process. As you can see, we're moving from a typical process to I'm calling automated process using AI, infusing AI in the process that eliminates a lot of the people having to enter data in different systems, provide the guidance, and learn as we go. Every interaction of this process, there is a learning process happening as well in this process. That's what we mean, intelligent process automation from before. Okay. If you go to the next slide, please. This one is, again, the idea of using what I was talking about, a hybrid multi-cloud capabilities. Again, ability to run your application in any place, anywhere around the globe. I believe we all know the company, one of the major players in the oil and gas industry is Schlumberger, right? Schlumberger, they have a whole offerings for the upstream oil and gas. from seismic interpretation, where is the oil, to operations and getting the oil off the ground, etc. So in their situation, they have initially offered their solution in 2 clouds. This was expensive for them because they have to maintain this solution in 2 environments, but they were not addressing the needs of the clients. For example, whenever they were providing the offerings, the solutions in China, Alibaba was the provider the clients they wanted to use, and they were not able to do this in Alibaba or provided this on premise and so on. By using the idea of a hybrid multi-cloud, they were able not only to deploy this solution in whatever the client desired environment, but also reduce the overall total cost of ownership of the solution they have, maintenance of what the applications are. But that's the way we are working in this case, Schlumberger, on leveraging this technology there as well. Okay, so that's it. Now, if you can go to the next slide, I'll have to wrap up very quickly. So how we bring this to reality now, right? One is about, the architecture decisions. It's typically, it's very, very important. It's more like the analogy, how do you build a nice home, right? You're not going to build your home one piece at a time without considering where we're going. You need to have your overall design, your blueprint of this thing. So understanding in your vision where you're going to be running, which applications, where will be very, very important. That's a typical conversation that we have. The second one, understanding on leverage on what you have already. You may have already capabilities about integration, etc. How we can leverage on this, and understanding the additional capabilities that we need to bring to the table to allow you to do the third box here on the bottom left, the use cases. What are the problems that you have to tackle now? For example, suppose quality is your problem, then you want to tackle the quality problem there. And then from this, of course, it's going to be a number of areas that we want to cover, and then we can have a deployment plan. And ideally, you should have a plan that's self-funding as well, right? So the benefits you're getting from one implementation is going to pave the way for the next one. That's in a very simplistic, the roadmap on how we can realize the value by bringing this technology to the plant floor. And then how we bring this to reality, the next slide, please. The concept of a garage, right? If you can go to the next slide. In our case, the idea is in the garage is a place where startups can do things very, very quickly as well. They can prototype. If you can go to the next slide, please. Yeah, it's a place where you can prototype your capabilities, quickly test if something is I don't know. If you can go to the next slide.
Getting into advance, so let me work on it. My apologies.
Okay, no problem. All right, okay. I'll talk about it, then we can. But the concept of a garage. The garage, as I was saying, is a place where you can quickly prototype what we're doing, test an idea, brainstorm with other colleagues on what you are trying to do to fix the problem, right? Look at more from what we're going to do first, and then how we're going to be using technology in order to enable that process. Not only stay there at the concept level, but also do this in a more, bringing this to the enterprise level as well. So we create a number of, we call manufacturing 4.0 garages in IPM. And that's where we have the machinery. I mean, we can go there. We have equipments from, you name it, from ABB, from Siemens, from Schneider, PLCs and whatever. So we can work with the clients in kind of testing a given situation they have, mimic what they have in a plant, show them how this is going to work, and agree on how a given model could be built or whatever. So the garage is another very important piece of the puzzle in order to go from what we're calling from tell the story to show how this happens in the actual factory there as well. Okay. So I rushed a little bit to a number of things, but I believe I gave you a broader picture on what we're trying to do. Going back to the topic, realizing the promises of the Industry 4.0 in the plants as well, by bringing these technologies to solve real problems of our clients. Paul and Rod, back to you.
Yeah, thanks, Jose. First of all, great overview of the 9 strategies of Industry 4.0, and the questions that I've reviewed, all of them are great. Address all of them. Again, if you have any questions that you haven't posted, please do post those, And if you could read, and just to make sure that none of the questions that you're about to ask have already been posed, and if they have, again, go ahead and vote for those so that they can rise to the top. So first of all, I'll take the first two questions, Paul. One's real easy. Jose, will a version of these slides be available for the general population? Great. And so, yeah, we'll get that out to you attendees as quickly as possible. With any new technology, Jose, comes the great question of what happens to those employees that are out-teched as a result of this. So large numbers of out-of-professionals, it doesn't bode well for social harmony. What plans are industry leaders making to handle the number of people that are rendered redundant by automation under Industry 4.0?
Yeah, I think this is a great question. It's a very important question as well, for sure, right? I mean, of course, this is a transition that's happening, and not only now, but it's happening over time as well. In everything we do in our lives, I think there's more and more we're going to be using more, let's say, our brain rather than the physical capabilities we have there as well. There needs to be a plan for every company to retrain the employees, to allow the people to use these technologies because they can become much more productive. They don't need to be in the environment that's very dangerous for their own safety, etc. So, but this is a program that companies are doing, and we see this more and more happening in the manufacturing industry as well. It's becoming more like the analogy I usually make is to do like as a video game, more or less. You're going to be operating your robot or your processes now using a joystick instead of going there by yourself and doing the work. But again, it's a retraining process that needs to happen. It is a natural evolution of us bringing technology into the industry there as well. But still, there is, of course, a very, very important piece of the human in the puzzle there. So not everything is going to be, automated, right? Sometimes I work with clients, they are asking about the dark factory. The concept of a dark factory is a factory. There's no more need for lights because only robots are working. There's no more people there. We're still, I would say, far away from this process, right? Again, it's more what are the key decision makers, how we as human now are directing the machinery, bringing additional intelligence, additional insights, but they kind of do the physical work on our behalf.
Excellent, Joseph.
Okay, so our next question is, what supply chain challenge do you foresee in all levels of manufacturing from 0 to, say, level 5?
Well, I would say, first of all, it becomes, as we all see with this pandemic situation, understanding your supply chain strategy as a manufacturer is very, very important. It's a more strategic view. If you rely on a single source coming from China, you may have an exposure on the supply chain. So there's I would say, understanding your sourcing strategy is the first step. Even before any technology, where is your suppliers, how they're located, and what is the single point of failures you have in your overall physical supply chain? That's one angle there. Right. So now, say that you did the strategic work, you define your sourcing strategy, primary suppliers, secondary suppliers, and whatever else you are less sensitive to disruption from the supply perspective. Now becomes how efficiently you're going to be running your supply chain. So the supply chain, systems have been evolving quite a lot. There's one angle of supply chain that focuses on a plant itself, let's say a company-centric. I have in my plants, let's say 10 factories. A factory has different product portfolio for each factory. They have the suppliers, probably close to the plants providing products and so on. One view is a very manufacturing-centric of the supply chain. But the evolution of the supply chain themselves are moving more toward a network because it's not only a supplier, it's a network of all the companies involved in the supply of the production of parts, the supply of parts, the logistics of bringing the parts in that can be subject to weather situations, to many other cases there as well. So the supply chain is evolving quite a lot. We call a supply chain network. In fact, there's a company here in Dallas, I'm not sure if you know, the One Network Enterprise. right? In fact, I was part of a company called I2 Technologies. I believe you heard about I2 Technologies here in Dallas. That's the reason I live in Dallas. I was the director for supply chain in the metals and mining in the pulp and paper industry for I2 before. I2 is no longer, it was acquired by a company called JDA, but again, this other company, several other companies came up, and this one is called One Networks. Very interesting approach to the network planning, the network aspects of the supply chain there. Again, a lot of things, the technology have evolved quite a lot in the supply chain.
Excellent, Jose. So you went over in pretty good detail. You dived deep in the 9 different strategies for Industry 4.0. And some companies may be looking at just one of those elements, some more than one, some the entire system. So can you apply your process on how to assess, create a plan, access that plan, implement it for, it could be, anybody that's looking for a small improvement or to a major operation like what we got to enjoy this past week?
No, absolutely. It depends really on the priorities of the clients. What are they trying to accomplish? Some is a very tactical problem. I have a problem with my quality or my equipments are not reliable for some reason. How can we, understand this, right? In tackle that problem in particular, but to do this in an organized fashion, because we don't want to do one-off, more or less. The point again on the analogy building a house, you need to have a blueprint on where I'm going to go. I'm going to start here, but I need to have the big picture first, right? If you're trying to think after the fact about this whole, how the piece fits together, you end up having to do a little rework, at least, that we don't want to avoid. Can I understand your strategy, define your architecture, and then we can tackle as big or as a small problem, depends on the priorities there as well. I think we cannot hear you, Paul.
Okay, now we're working. So our next question is, what path would you recommend for PhD students interested in joining the automated manufacturing industry?
As you noticed, it's a very broad topic as well. We can do 100 things, right? And find your passion, more or less, right? For example, very likely a PhD student is very good in dealing with complex data, more or less, understanding the data, how we can apply, either existing capabilities or develop new capabilities, new ways of tackle the problems in the data, more or less, right? So finding your passion first, what you really want to do, right? And maybe based on your undergrad work or the postgrad work as well, and from there really kind of engage with in a client or be part of a company that gives you the opportunity to really apply your skills in an area that you like the most, right? So yeah, for example, in IBM, right? Not talk too much about IBM, but we have a very large research center. We have 3,000 researchers. Have I think 14 research centers around the globe. One in Austin, in fact, the other one in California, Almaden, the other one New York, and so on, where we hire a number of PhD students to work on a variety of problems that we have, right? For example, one area that we are tackling as we speak is the sustainability. Sustainability is a very hot topic nowadays, right? In the whole energy transition that's happening in the industry. So again, there's plenty of challenges to work together with very bright PhD students.
That's great, Jose. Cody Hartfield reminded us of a program back in the 70s called Project Cybersyn. How influential would you say that those methodologies have been on Industry 4.0? Mm-hmm.
The Project Cybersyn, I'm not aware about that project. If you can elaborate a little bit more on this.
Back in the 70s, I was just in high school, so I'm not familiar with it either. I'll have to do a Google search while we address the next question.
Yeah. Yeah, there's a whole evolution. I have been around, not maybe the 70s, I also was in school, but around AI, right? The first wave of AI have been doing AI for a long time. There was a belief that for you to build an intelligent system, you need to separate, you need to bring the knowledge in. One is ability to process the knowledge. The other one is how do you capture the knowledge in a given field. For example, if you're doing cancer diagnostic or if you're doing diagnosis of a given equipment. So the first wave of AI systems was what we call knowledge-based systems, more or less. It was it was very powerful at that time. You have, the knowledge representation and you have an inference engine to process the knowledge itself, right? The challenge with that is really to represent the knowledge at that time. How we call knowledge engineers that are able to talk with an expert. Imagine if you go to a medical doctor in a cancer, tell me everything you know to diagnose cancer. It's not a very trivial answer to get, more or less. And sometimes even us to explain the knowledge we have is not very trivial. So there's methodology to do this as well. I'm not sure if this was related to the question, but I'm saying there's a whole evolution on this, and now it's all about machine learning, etc., that somehow allows us to train the system, not to to extract the knowledge from an expert.
I think you nailed it pretty well, Jose. I did a quick Google search, and it looks like Cybersyn was great-great-great-grandpa to Industry 4.0. So well done. Paul, you're on.
Thank you, Rod. The next question is really goes back to something I heard 4, 5, 6 years ago about some of the issues that the manufacturing floor has with automation, IoT sensors, et cetera. So this question is, the plant manager is also concerned with sustainability. So how does that fit into your model?
So there are several angles to sustainability, right? One, of course, if you look at the super majors, the oil and gas companies, they have their own strategy in the energy transition. If you look at a company like Shell, they're now investing in power generation, renewable sources, and whatever. This whole, part of the, what's happening in the automotive industry, for example, is the electric vehicles, the fuel cell vehicles. So there's one part is the whole, how can I say, evolution of the technology on how we're building the products themselves. That's one angle. This has two angles. One is the, designing a product to be recycled at the end of the life cycle, right? And the second one, what are the materials, the material science that you want to design in the products. So there's a whole focus of applying AI in the art of material science as well. So in fact, I was in a conference in Japan where I was the keynote, or I was the chair of the conference about smart materials there as well a few years back. But again, a revolution is happening in this area, and where you can use AI to help the R&D people of a given company to explore much faster the designs. What we could do before in few years, you can do now in much like 1/10 of the time to explore new properties, new materials, etc. And then leads to, for example, the whole plastic. How we can have a plastic that doesn't impact the environment or whatever. So there's a material side on this. There's another angle about, factories. For example, if you look at cement, just pick one, is a very, energy intensive, and the amount of CO2 that you end up generating is quite a lot. How we can now create, much more energy efficient plants, production operations part there. There's this angle on the sustainability there. So in other words, there's a large portfolio of things that are coming together. Even the supply chain, how we minimize the transportation costs, the logistics, and so on by tracking the CO2. Right. So again, quite a lot of agenda. More than happy to maybe either myself or invite a colleague to come and talk about sustainability itself. But it's a very big topic and it's core to industry.
Yeah, thanks, Jose. We probably have time for 2 more questions, unfortunately, and more are piling in here, Jose. So Bill Sproul brings a really great question here. What industry sectors have been the quickest to digitize, and which ones the slowest? And if I can piggyback on that, what opportunities have those slow ones lost?
Well, it's a very interesting question. And my angle is this. Sometimes, right, if you look at the oil and gas industry, they were far ahead because, again, the complexity of operating an oil rig, finding the oil, etc. So they were ahead of the pack, but this also creates a little complacency on them, how they're moving forward fast, more or less, right? On the other side, if you look at the mining industry was very like in the Stone Age to some extent. the speed in which they were able to move forward was much higher. Now they're, I would say, almost in the same level as the oil and gas, right? So that's one. If you look at the automotive industries as well, I'm talking about more initially natural resources. There's a kind of different players there, and some players catching up very quickly, given now the technology is cheaper and easier to consume. It depends on the vision of the executives of the company. If you look at in the process industry, by the process I mean pulp and paper, looking at the steel, aluminum, etc. They have been doing quite a lot of work already over the years in terms of the process, because it's a necessity of the production, optimizing the energy efficiency, etc. They were quite ahead of this, but now the focus is how I better utilize, AI analytics to improve my quality, improve the utilization of my facilities as well, and better manage my energy grid. So they're doing quite a lot of work in this area as well. And then if you come to the assembly, the discrete industries, we're talking about a variety of things, either producing a component, a pump, or producing a car. There's a whole revolution happening in the automotive industry, triggered by what's happening at Tesla, for example. Tesla not only disrupted the process from bringing the electric vehicles, but the way that car is being built as well, right? They have much less legacy that they have to do to design a new car compared to the automakers, for example, right? So every industry, there's a little own dynamics that's happening as well, of course, triggered by the competition, triggered by the new possibilities. And sometimes if you have a big legacy, this holds you up to move very fast going forward there, right? So it's, I don't know if I gave the perspective, but that's the different dynamics that's happening across several industries there.
Well, I guess doggone it, we've gone maybe a little bit beyond our time, but there's a couple more questions. Paul, one last question or not?
Oh, sure, why not? Let's see what we got here. So, Jose, what is your perspective to respect with private networks, specifically as it relates to spectrum? Are enterprises looking and capable of securing the needed spectrum to do the most work with MNOs?
Yes, it's a very interesting field, right? There's a lot of moving parts to this one, right? As I was saying, in the private network part, or the private 5G or whatever private network, the spectrum, there are some spectrum that companies are using, and this varies by country, by the way, right? I will give you an example in Texas, where they're using one of the spectrum to use to create their private 5G in a major plant they have there as well. That's one. And this is, they're securing the spectrum, and we're working with what we're calling the NEPs, network equipment providers. Company like Cisco, I think we have a very interesting company here in Texas, GenXCon as well, that are doing work with them now, right? They were in a Capital Factory event. We are now bringing them a number of opportunities together with us. So one is, again, any network equipment providers, understanding a given spectrum that the companies are securing in order to create the private 5G. The other angle that we're seeing are the other stream are the telcos, more or less. The AT&Ts, the Verizons, or whatever, of course, they have their network, and then they have the public 5G, but they want to go into the private 5G as well, and connecting the two worlds as well there. And then we have the cloud providers providing the network management capabilities there to the factories there. So again, many parts. Again, we are waiting to see how these things are going to shape up, more or less, and there might be different trends, depends on where you are, which country you are, and the regulations for the country itself, right? In fact, possible, maybe in one potential case, we can talk about specific implementations and the challenge, the design considerations for 5G in manufacturing. There's a lot of ground to cover.
Thank you, Jose. And thank you, everyone, for great questions. And as you know, we've run out of time, but Jose is going to be part of the networking time, as are all of you. In fact, right now, we're going to officially close today's presentation, but we do hope that you'll remain on for an extended networking session. And so before we do that, please join me in thanking Jose. Favilla, thank you so much for a great overview. I also want to quickly call your attention to the March 26th Tech Industry Luncheon. Emerging Company CEO Award recipient from last year's Tech Titans Award Gala and the CEO of Trintech, Teresa McIntosh, will headline today that lunch presentation. By the way, due to spring break, the presentation will be held on the 4th Friday instead of the 3rd, so that's March 26th. Go to techtitans.org for more information on that. So again, welcome to our general networking session. In a moment, we'll be moving from the presentation form to the networking form. You will find out who is in attendance by looking at the names on the chat. And to change tables, simply double-click on the center of the table that you wish to move to. You'll also see a set of elevator buttons on the left hand if there are more areas, more tables that might be interesting to you. Click on that floor you wish to go to. The program will take you there. During that network session, if you want to learn more about UT Design Capstone, hit the sponsor logo and learn more about their program. For the next 25 minutes, we'll be in networking mode, and then we'll close no later than 1:45. So thank you again, Jose. Thank you, audience, for joining us, and we hope you have a very safe weekend. And let's go to networking mode now.
Thank you.